Introduction. The largest public source of air quality data is the community project OpenAQ. This website takes measurements from individuals across the globe on various chemical densities. While OpenAQ gives point and space data points, we want to derive an air quality map to cover the country. Motivation. With this project, we would like to increase air quality knowledge across the country. Hopefully, this approach can provide some context for air quality in your hometown, even if you do not have a local air quality sensor. Air quality is related to public health, which is becoming an ever more pressing issue. And maybe this project will inspire you to bring an air quality sensor into your local community. Algorithm. There are two primary geospatial interpolation methods, inverse distance weighting or IDW and kriging. We chose IDW to reduce the computational costs. For any location, the estimated pollution density equals the weighted average density of nearby sensors. That average is weighted by the inverse of the distance between the estimate and the observation. Implementation and technology. We use several technologies discussed in the class: Amazon Web Services, Hadoop, Hive, and S3. We also use some other technologies such as Athena and AWS Lambda functions. Bitbucket hosted our Git repository. Data and pipeline. The raw data is hosted on the OpenAQ API. This data on dirty air is relatively clean and does not require much scrubbing. We gather the data from the API into our local AWS Athena database. Then there are these Lambda functions, where the distributed processing occurs. Each instance of the function takes as input sensor data for a given date and chemical, as well as a mesh of GPS coordinates to compute over. As output, the function creates a color for each GPS coordinate in the mesh. The controller and dispatcher functions offer a distributed MapReduce functionality. These Lambda functions dump their output into a project bucket, which is read by the front-end D3 visualization. There are over 225 gigabytes of data across more than 483 million records from January 2014 to the present. And this is what the resulting website looks like. Experiments and results. We ran two experiments for this project. One involved computing the power parameter for the IDW method alongside the K parameter for the ball tree method. The power parameter specifically is the exponent of the weighted average weight. For instance, as a weight, do we use 1 divided by the distance, 1 divided by the distance squared, 1 divided by the distance cubed, or so forth? The second experiment involved the calculations for coloring the map. The distance parameter is the number of kilometers nearby the sensor, which we assume are known values with fully saturated colors. The slope parameter is the rate at which saturation decreases and the colors approach gray. A third parameter, the percentile, is included in the report and determines the estimate value assigned to red.